Hi, we have seen the detailed algorithm for breadth first search. Now I am going to walk through of the algorithm. I am going to consider the algorithm and walk through with an example. We will consider the same example. Look at it 0, 1, 2, 3, 4, 5, 6. There are 7 nodes and the edges. We are going to start from 0. So as per the algorithm, we will have to do the initialization. What is the initialization? We will have the first q equal to only 0, because 0 is the element from which we want to search. We want to begin our search. So the initial node is 0. Put it inside the queue. Similarly, the set explode. We have not explored anything. So the set explode is empty. And then the parent. So since no parent has been assigned so far, we will consider parent of I equal to I. Then level. So we will keep everything as 0. Nothing is assigned a level. Solution. Where is the solution? As we want to explore all the nodes, we are going to consider the example as the solution is not available anywhere. Finally, we want a failure. We want to say that the search is a failure. So it is not available anywhere. The medicine is not available anywhere. Now, let us start with iteration 0. Look at it. Iteration 0. Pop the first entry from Q. From the Q has only one entry, 0. So pop. When you pop, you will have to first verify whether the solution is available in 0. So solution of 0 is false as per our assumption. So it is not available. So you add 0 into the set explode, because 0 is explode. Now we have to look at what are all the adjacent vertices of 0. What are all the adjacent vertices of 0? 1 and 6. Look at it. For 0, 1 and 6 are the adjacent vertices. So, adjacent vertices are 1 and 6. It has not been explored. 1. It is not explored. 6. It is not explored. 1. It is not already in the queue, because in the queue only 0 was there. And when we pop, it comes out. Now actually Q is empty. So if you consider 1, it satisfies both conditions. It has not been explored. It is not in the queue. So add 1 to the queue. 6 is not explored. It is not in the queue. Add it. Now 0, the next level 1 and 6 have come. So vertex 1 is neither explored nor in the queue, so add 1 to the queue. Now, what is the parent of 1? 0, because from 0 only 1 was adjacent. Now, similarly, level of 1 is level of 0 plus 1. So, next level. Similarly, you consider vertex 6. It is neither explored nor in the queue, so add it to the queue. Now, the queue becomes 1 and 6. So the queue will have a front and a rear. Look at it. This is the way it is. So there is a queue. 1 and 6 are in the queue. 0 is already explored. This is the current status. What is the current status? The current status is 0 is already explored. 1 and 6 are waiting in the queue. So far, 0 is the parent of 1 and 0 is the parent of 6. 6 and 1 are in level number 1. 0 is in level number 0. Now look at it. Solution, explode, parent, all these things are there. Now we move on to iteration 1. What is iteration 1? When we begin the iteration 1, the current status is vertex 0 has already been explored. List of explored set will have only 0. Q has two elements, 1 and 6. Now, step number 2 has to be done. What is step number 2? Pop the Q. If you pop, 1 will come out. So this is the loop. So pop and verify those two conditions and so on. Now, if you pop, we get 1. We have, what are all the adjacent vertices of 1? 0, 2, 4 and 6. Among them, 0 is already explored and 6 is already in the queue. So only 2 is adjacent to 1, which satisfies the two conditions. So look at it. Adjacent vertices of 1 are 0, 2, 4, 6. We must check these two conditions. 0 is already explored, but 6 is already explored. 2 is neither explored nor in the queue, so add to the queue. Similarly, 4 is neither explored nor in the queue, so add 4 to the queue. Now the queue becomes 6 to 4. Look at it, 6 to 4. So this is where we are. 0 is explored, 1 is explored. Now the queue has 6, 2 and 4. Now what should we do next? We will have to pop 6 from that. So what we need to do is pop 6 and verify whether 6 has the solution. No, it doesn't have the solution. So now you make 6 also explode, make a tick mark. You add it to the explode set. Now for 6, what are all the adjacent vertices? 0, 1, 4, 5. 0 is already explored, 1 is already explored, 4 is already in the queue, so ignore it. Now only 5 has to be added. Only 5 has to be added to the queue. Now 5 is coming after 6. So we have parent of 5 equal to 6. So that is where we are. So after this, what is the queue? Queue will have 2, 4 and 5. So this is the current scenario. So 0 is already explored, 1 is already explored and 6 is already explored. And what is the queue? The queue has the next layer 2, 4 and 5. Look at it. It is there. Now we will move on to the next iteration. Pop. If you pop, 2 will come out. 2 will come out because 2 is in the front. So you pop the entry in the front. Now do the same thing. So check whether the solution is available in 2. No, it is not as per our assumption. Now add 2 to the explode set and then identify the adjacent vertices of 2. Look at it. For 2, 1 and 3 are adjacent. 1 is already explored. Only 3 is pending. So adjacent vertices of 2 are 1 and 3 and vertex 1 is already explored, so ignore it, and 3 can be added. Now what is the status of a queue? 4, 5, 3. So this is the current status. 2 has been explored, 4 and 5 are there and 3 is also added. Now we will repeat. Now pop. When you pop, what will you get? You will get 4. Verify whether the solution is available in 4. If it is not, we assume that it is not available and then add 4 to the explored set. So now the explored set will contain 4 also. Now what are all the adjacent vertices of 4? We have the adjacent vertices of 4, 1, 3, 5, 6. What happens? For 4, 1, 3, 5, 6. So 1 is already explored, 6 is already explored. Between 3 and 5 are already in the queue. So what happens is, so 1, 3, 5, 6. So vertex 1 is already explored, 6 is already explored, 3 is already in the queue, 5 is already in the queue, so nothing to be added. Now the current queue is 5 and 3. So look at it, this is the status. So 5 and 3, that's all, they are there. Now iteration 5, the next iteration is then pop 5. So node 5 will be popped. Check whether it is the solution is there in 5. No. Then you mark 5 as explode. Then for 5, you look at the neighbors, no more to be added. Now finally, you have only 3 in the queue. Now the next iteration is take 3 and explore. Now there will be no more nodes available for adding to the queue. So finally the queue becomes empty. So when the queue becomes empty, we can stop. So that is the way. Now things 0 is in level 1, the next level 1 and 6, 2, 4, 5 is there, finally 3 is there. So this is the way the algorithm runs. Thank you.